Hi everyone, welcome to our lightning talk. Today we'll be talking about the sorption of chlorinated ethenes in soil impacted by microplastics under variable ionic strength. My name is AJ and I'm a senior in the Department of Biological and Environmental Engineering at Cornell University.
Hi everyone, my name is Allison. I am a Master's of Engineering student, also in the Department of Biological and Environmental Engineering at Cornell. So to share a bit about our project, some background into these contaminants we're investigating, chlorinated ethenes, including PCE and TCE, are known contaminants from many industries. And then we have microplastics as well that are known contaminants. Both of them emerging and threatening soil and groundwater quality throughout the world. Chlorinated ethenes and microplastics have been well studied individually, but there's recent research into their interactions, which is relatively understudied in terms of how they impact each other, sorbing to the soil. The microplastics themselves originate from sources like runoff, landfill leachates, textile discharge, and are a big issue recently as an emerging contaminant. And the chlorinated ethenes as well are known to have many health risks. Ionic strength has also seen to increase or enhance sorption due to the salting out effect and more of that contaminant ending up in the soil. So both of these together should be investigated under all these effects.
So to go over briefly about our materials and experimental plan for our studies, our overarching objective is to develop an experimental matrices of treatment groups that allow us to isolate each treatment of effects for sorption kinetics while keeping all of the variables constant. So the different treatment groups that we are considering for our study are microplastic polymer type, specifically polypropylene and polyethylene, or no microplastic at all. A dechlorination product, which include perchloroethylene, followed by trichloroethylene, followed by cis-dichloroethylene. We also have a range of concentrations, ionic strengths, and natural soil type, both being Martin and Ukport, which are both native to Northeast United States and have variable physicochemical properties like pH, organic content, etc. So an example experimental matrix that's being conducted right now for our studies are where we control Martin soil and keep it at a constant 30 millimolar ionic strength, but we vary the polymer microplastic type and the chlorinated ethene product. So as you can see, that leads us to six distinct, I guess, experimental groups that we can analyze to kind of elucidate out the effect of these varying treatment groups on sorption itself. And to kind of dive a little bit deeper into what I mean by our treatment groups, so this is an example vial of a headspace chromatography vial that would be our quote-unquote sample. In each sample, there is a soil type, so that can either be Martin or Arkport. And then we have our microplastic type, which is either polyethylene nodule or a polypropylene fiber, or just no microplastic at all for our control groups. And then followed by a chlorinated ethene product, so either TCE or PCE. We then rotate that for 1 week to reach equilibration with the liquid phase in our sample. Um, and then we conduct a liquid phase analysis to get our concentration in the water. We then replace that with methanol, the liquid phase, shake that for 48 hours, and then perform a solid phase analysis also on gas chromatography to get a solid phase concentration, which will then allow us to get our KD value, or basically the equilibrium constant between the liquid phase and the solid phase, which gives us qualitative insights into sorption behavior.
So just some real life pictures of what we got going on in the lab. First, that step where we have inputting all these factors from the matrix, the plastic fiber that's chosen, the different types of soil, and then an ionic strength and the type of chlorinated ethene. These are what the shakers look like down here on the reactor equilibrate symbol there. And then we also have the different samples that we end up taking, the liquid phase sample, the methanol extraction, and then the solid phase sample. And those samples will tell us how much of the chlorinated ethene is left in each of them. And that way we can make some future decisions about cleanup of chlorinated ethenes and microplastics together. So come by our poster to learn more and see our results of what we're going to find here. Thank you.
Thank you.